So dear students, in this video we are going to start our chapter 2, and that is electric potential and capacitance. So this particular chapter is about two topics, and they are, one is electric potential and the second one is capacitance. So the whole chapter is based on these two topics. First of all, we are going to discuss the first topic, that is electric potential. Electric potential. So to understand this particular topic, that is electric potential, you should have the concept about this particular potential or potential energy. So firstly, if you have enough idea about what is potential or potential energy, then it is easier for you to understand what is electric potential. So first of all, we will do a bit on the potential energy, then we will go to our electric potential. So potential energy, we have discussed this particular topic, potential energy, in our class 11 and its relation with the work. So how work and potential energy were closely related to one another. So we want to revise that very much quickly right here by taking an example of gravitational potential energy. So let us quickly do what is potential energy. Let us take there is an object on the ground. Let us take there is an object on the ground of mass m, and consider this ground to be at zero potential. Suppose this ground is at point A, and just imagine potential energy, or let us assume potential energy at the ground to be zero. Let us denote the potential energy at the ground by UA. So UA means potential energy at the ground, and let us assume it is to be zero. And if we left it to a point B, which is at height of h from the ground, then we need to do some work to lift this object from point A to point B. We need to do some work, and we know the work done in this process will be equals to the force applied the external force applied to lift this object, multiplied by the displacement, how much you are lifting the object above the ground. So work done is basically, it is a dot product between external force applied and the distance you have lifted. And since the external force applied and the displacement, or the distance you are lifting it, are along the same direction, so this dot product just gives me fx d or h, fx d, because cos theta here will be 1, because theta is 0, because force and displacement are along the same direction. So work done in this case will be fxt external, F external into D. Now what is external force in this case? External force in this case is nothing but it is gravitational force itself, opposite in the direction. So gravitational force is in this direction, Fj is in this direction, so F external is opposite of that. means external force will be mg because gravitational force is minus mg. So Fg is taken to be negative because it is along negative direction, and F external will be equals to positive mg because it is towards the positive y direction. So it is our convention. So W is equals to mg into what is the distance or displacement? Displacement will be h. So work done in this process will be equals to mgh. That means the work done lifting this object from point A to point B will be equals to mgh. And since gravitational force or gravitational field force is a conservative force, which means the work done in lifting or displacing the object will be stored as the potential energy. So what is a conservative force or field? One of the property of conservative force or field is the work done in lifting the object will be stored as a potential energy. So all the work done will be stored as a potential energy. That means this work done is nothing but this is the potential energy at point B. So work done is actually all the work done is stored as the potential energy at the point B. So work done and potential energy are related this way. Or you can write this in general. You will write this as all the work done will be equals to the difference in potential energy. That is UB minus UA. So this is the exact relation between the work and potential energy because since like in this case UA is 0. In this case UA, we have taken UA to be 0, so work done is just UB minus 0, that is UB. But in general, the work done in lifting the object is nothing but it is the difference in the potential energy between the 2 points. That is this one. So we will take a more closer example than this. Suppose the object is not taken from the ground, but it is taken from elsewhere. Then what will happen? Suppose the object was here firstly, and it is taken to this height of h. This is point B. So the object was at point A, then it is taken to point B, which is at h height from the h height from the ground, which is at h height from the ground. That means the point B is at h height from the ground, and point A is at small h height from the ground. Then what is the work done in this case? So work done in this case will be, so it is taken from point A to point B, so work done in this case will be again F external dot displacement. Since displacement and external force applied are in the same direction, so work done will be F external D, or work done is F external is mg, and this displacement is nothing but this displacement is from here to here it is capital H, and from here to here it is small h. So this difference is nothing but it is capital H minus small h. So it is taken by a height of h minus h. So what is this? So this is the mg. If you multiply inside the bracket, it is mgh minus mgh. But what is this capital mgh? See, this mgh was nothing but it is the potential energy at h height. That means this mgh will be potential energy at h height, and this h height is nothing but h height is a point B. That means it is the potential energy at point B. So work done will be potential energy at point B minus, what is this mgh? Mgh is nothing but it is the potential energy at h height, as we saw earlier. That means mgh is nothing but it is the potential energy at h height, and that is potential energy at point A. That means we have in general what we have saw here is work done in taking an object from one point to another is nothing but it is the difference in the potential energy between the 2 points, or the work done in taking an object from lower potential to higher potential is the just difference between the 2 potentials. So let us now go to our electric potential energy. Let us go to our electric potential energy. So in electric potential energy, in gravitational potential energy, you have gravitational force or gravitational field. Now in electric potential energy, you have an electric field. Suppose you have an electric field this way. Now suppose you are taking a unit positive charge or Q charge from this point to this point. You are taking a Q charge from point P to point R. In an electric field, you are taking a Q charge from point P to R. Then you need to calculate here what is the work done in taking the charge from point P to point R. Now what is happening here is the Q charge is experiencing the force in this direction. That means electric field is driving it towards this direction. That means electric field is exerting the force in this direction. This is the direction of electric force, Fe. This is the direction of electric force towards this direction, similar to gravitational force. Now in this case we have to utilize the force, external force, opposite to the electric force in this direction. F external will be in this direction. So work done will be nothing but if this displacement is R, then work done will be F external dot this displacement R. And we know this external force will be opposite to our electric force. That is opposite, negative of electric force. Okay, I'm writing it again. This external force will be opposite to electric force. That means if you utilize electric force, then it will be minus Fe. In place of F external, it is minus Fe. Electric force and external force are opposite, so minus Fe dot R. So this is the work done in for bringing a charge from point P to R into in terms of two different forces. One is external force and another is electric force. Okay, so in similar manner, this work done is nothing but we know this work done F external dot R. Let us write it in terms of the external force. So this work done will be equals to, as we saw earlier, difference of potential energy. So this will be just difference in the potential energy, UR minus UP. So the external the work done in bringing a charge from point P to R will be the difference in the potential energy of the 2 points. It will be equals to UR minus UP in similar manner. So this is the work done in bringing, because your electric force or electric field are conservative too. Since electric force or field are conservative, so work done will be stored as the potential energy difference between the 2 points. So work done in bringing this charge from point P to R is just the difference between the potential energy between the points R and P. Now let us specify this one. Let us make more specifically. If this particular point P is okay, let us make more specific. Suppose you have a positive charge at this point, and suppose there is a point P here or R point here. Now since the positive charge electric field is towards this direction, the electric field of this positive charge is towards this direction, that means at this point also the field are outward. That means if there is a positive charge at this point, it will experience a force towards this direction. Now if you are bringing a positive charge Q from infinity, if you are bringing a positive charge from a point infinity to point R, then what will be your work done in this case? Now similar manner, the first point is infinity and the second point is R. You are bringing a charge from infinity to point R. So in this case the work done will be UR minus U infinity, because earlier I was bringing it from point P to R, so work done was UR minus UP. Now in this case you are bringing it from infinity to point R, so your work done will be UR minus U infinity. Now assume, or what we take is, assume potential energy at U infinity to be 0. So for the electric force or electric field, we take potential energy at infinity to be 0. So in this case, work done will be just equals to the potential energy at point R. So there will be two definitions of work here. So first definition will be this one. The first definition is potential energy difference, and this is the potential energy at any point. So the potential energy at any point can be defined as the potential energy at any point is defined as the potential energy at any point is defined as, suppose at point R or any other point, may be defined as the work done in bringing a positive charge from where? Infinity to the very point. Meaning, if we bring a positive charge from infinity to at any point, then the total work done in this process will nothing but it will be the potential energy at the point itself, like this. In this case, the potential energy at bringing positive charge from infinity to R is nothing but it is UR only, that is the potential energy at that point only. Therefore, the potential energy at any point is defined as the work done in bringing a positive charge from infinity to the very point. So this is a little bit maybe it is a little bit tricky for you to understand this, but if you see it carefully, or if you see it again and again, then you will understand it. So we are going to continue in the next video. Thank you.